In this video, we are going to discuss Unit 5 Interfacing Microcontroller uh, for the topic Timer Programming. Objectives of this video are: we will list out timers of 8051 and associated registers for them, and we'll see various modes of 8051 timers and how to program those timers. Microcontroller 8051 has two timers and counter, which can be used for uh, delay generation and counting external events. We can select either timer or counter. Timer 0 and timer 1 are 16-bit registers which can be used separately as low byte and high byte. For example, if I take timer 0, TH is high byte register and TL is low byte register. Likewise, for timer 1, TH is high byte register and TL is low byte register. Since it is timer 0, we mention it 0 here. Since this one is timer 1, we mention it as 1 here. So both of them combined together makes 16-bit timer 1 register. Likewise, these two combine together to form timer 0, 16-bit timer 0 register. So let's see the format here. So this is the format for timer 0 register. D0 to D7 is called as TL0, low byte timer 0 register, and D8 to D15 is called as TH0, timer zeros high byte. Similarly, we have format for timer 1. So this is the format for timer 1, TL1 as well as TH1. And now these timer registers can be used in normal instructions. That is, just like we access A, B and R0, R1 registers, we can use this TL0, TH1, these timer registers as 8 bits. Now take for instance move TL0, comma, hash data is given. So this data 4F will be moved into TL0. On similar basis, we can use this instruction also. Move R5, comma, TH0. The value of TH0 will be moved into R5. So in this way, we can access the timer registers. And then let's move on to the next register, TMOD register. This TMOD register is nothing but mode register, which will help us to decide the mode of the timers used here. TMOD register is 8-bit register which is used to set the timer mode for timer 0 as well as timer 1. We have the format here. The timer for the timer 1, we have these bits. Let me mention it as D0, D1, D2, D3, D4, D5, D6, and this one is D7. So bit D4 to D7 are dedicated for timer 1, D0 to D3 are dedicated for timer 0. So let's see what are these. Gate pin, that is D7 for timer 1 and D3 for timer 0 will be enabled whenever we have the int 0 or int 1 pin high and TR0 and TR1 is high. That is, the gate pin will be enabled whenever int 0, int 1 and TR0, TR1, these bits are set. Okay, so these int bit should be high as well as these TR bit should be high. Then only the gate bit will be enabled. Enabled in the sense the bit value will be 1. If we want to disable it, we are not selecting the timer. In such case, this bit is 0. So timer is not selected. Okay. Next, we have the bit D6 as well as here D2. Bit D6 as well as bit D2, which will identify the timer or counter modes. Okay, whether we are taking a timer or as counter. This particular bit, if I put this bit as 1, if I put this bit as 1, then the entire timer 1 is taken as counter. Whereas if the bit is 0, then the entire timer 1 is taken as timer. So what is the difference between counter and timer? Counter starts counting from 0 to some fixed value, 10 minutes or something like that, 10 counts or something like that. Whereas timer will start from a particular high value and gets decremented. So in this way, counter timer function will be there. Now the same thing happens here also. If we put 1 here, then the timer 0 is used for counting purpose as counter. If I put the 0 here, then the timer 0 is taken as timer for the entire 16 bit will be taken as timer in this case. That is whenever t equal to 0 here. Okay, and now let's see how the modes will be changed. Modes will be changed using, we have the combination of M0 and M1 for timer 0. Similarly, M0, M1 for timer 1. So the combination is mentioned here. If we have 00 bits, this is taken as mode 0 and mode 1 and mode 2, mode 3. Observing the combination 01 we have mode 1, 10 we have mode 2, 11 we have mode 3. So what are these modes? We in mode 0, the timer 16-bit timer will be acting like 13-bit timer. For instance, we have 8 bits here, 8 bits here as timer 0. So this is 16-bit register. In this, only 13 bits are used for counting purpose. Only 13 bits are used for counting purpose in mode 0. And otherwise, we can take it as 8-bit timer or counter with TH as, that is, higher value will be taken as prescaler, 5-bit prescaler here, 5-bit prescaler. That is, we have 8-bit TL and this one is TH, 8-bit. Okay, now we can observe that in mode 0, this is taken as 13-bit register, or otherwise you can mention it as 8-bit counter will be there in TH. TH 5 bits are taken as prescaler here. What do you mean by prescaler? Certain fixed value will be there. As I said, for timers, we have some fixed value from 5F. We need to go for timing purpose. So the next decremented value will be 5E and then 5D and then 5C. Like this, the value gets decremented. So this value 5F is taken as prescaler. So that is the condition in mode 0. On similar basis, mode 1. Mode 1, the entire 16 bits are taken for a counting purpose. Entire 16 bits will be taken for counting purpose. And we can use TH and TL in a cascaded manner with no prescaler because all 16 bits are used for counting purpose. Next, mode 2. Mode 2, we have 8-bit as auto reload as well as 8-bit for counting purpose. That is, TH holds the value for reload, TL holds for time overflow. We are using the timers separately here, just like TH for auto reloading the value, TL for overflow. That is, for example, I'm reloading the value. Let me start the count. Always should start from 5C. So I want the counter should start always from 5C. After getting counted up to some 8E, again I want to start from 5C. So this one becomes my reload value. Since this is 8-bit, the reload value will be in TH. Whereas whenever the overflow, this 8E should be taken as overflow here. That value can be observed in TL. So this is the intention of mode 2. Next one is split timer mode. Split timer mode. We can use TH as well as TL separately as a counters. So this becomes one counter, this becomes one counter. Or this becomes one counter, this becomes timer. In that way, we can swap and take the timers separately. So in mode 3. So this is about modes of timers here. And very important condition that we need to observe here is clock frequency. So clock frequency is very important. We need to calculate the clock frequency so that internal circuitry of the microcontroller, which provides the timer 1/12 of the frequency of the crystal, which is attached to the microcontroller's machine cycle. And for example, let me tell you, we have crystal frequency of 11.0592 megahertz, and then microcontroller will provide 1/12 of the frequency of the crystal. So finally we can calculate timer clock. Timer clock frequency will be equal to crystal frequency divided by 12. That is equal to, we can mention it as 11.0592 megahertz divided by 12, which will be equal to 921.6 kilohertz. So this is in frequency. If we want, we need to find time period. F is equal to 1 by T. So from this we infer time is equal to 1 by F. Obtained value is 1 by 921.6 kilohertz. So this is approximated to 1.085 mu seconds. So this becomes the time period. Now, how the timers will be counting? Let's see. In mode 1 programming, if we are using it as 16-bit timer, the value starts from 00 to FF. These are the maximum and minimum values. And now TH and TL are loaded as 16-bit values initially. Then the timer is started by setting TR0 for timer 0, and timer 1 is used by setting TR1 for timer 1. And now timer counts up till it reaches its limit of FFFFH. After that, it rolls over from FFFFH to 0000H. Now let's go for setting timer flag. Then when the timer flag is raised up, you can stop the timer by using clear TR0 or CLR TR1. This is for timer 0, this is for timer 1. After the timer reaches its limit, rollover occurs. The registers TH and TL must be reloaded with the original values, and before that TF must be reset to 0. So these are the steps to be followed for programming the timer. Thank you.